2022 Waec question number 2. This is the diagram of the question. This is the boiling tube. This is the scale. This is the beaker. This is water. This is the dry sand or standard mass to be here. You are provided with transparent beaker, fennel calipers, standard masses. Standard masses 2 gram, 5 gram, 10 gram, 15 gram, 20 gram, 25 gram. Pieces of string. Pieces of string, forceps, boiling tube, gas cooker, dry sand. Weigh the boiling tube to know its mass and record it. Measure the depth of boiling tube. Load the boiling tube with standard mass of 5 gram. Determine the depth. Tap it to oscillate it 10 times. Read and record. Read and record the time taken for 10 oscillations. Evaluate T square, L. 5. Repeat the procedure MA of 10 gram, 15 gram, 20 gram, 25 gram. 5. Plot the graph with MA on the vertical axis and T square on the horizontal axis, starting both axes from the origin. 6. Determine the slope S of the graph and intercept E on the vertical axis. 7. Calculate your readings. 8. Determine the average value of L. 9. Evaluate K is equal to 4 pi square S all over Q. Pi is equal to 22 over 7. 10. State 2 precautions that are necessary to ensure accurate results when performing the experiment in the laboratory. B1. List the forces acting on the loaded test tube as it performs oscillation in the water. B2. Explain why the amplitude of oscillation of loaded boiling tube decreases with time. Now, the mass of boiling tube has been determined. The mass is 30 grams. The depth of the beaker of water in the beaker has been determined. It is 10.00 centimeter. The formula to find the mass is ME is mass of beaker together with the mass or together with the sand or test tube minus mass of empty boiling tube. Now, we want to start. These are the masses. These are the masses. This is stop clock. This is beaker. This is boiling tube. Now, we've already determined the depth. Now I put a mass of 5 gram inside the boiling tube. To know the depth, this is the depth it reached. If you look at this, the maximum height of water is 10, and this is we are going to remove this. It stops at 9. We are going to remove 9 from 10 to give us the depth is 12 centimeter, and this is the stop at 9. So when you remove, this is for 5 gram, this is for 10 gram, 15 gram, 20, 25, 30. Now the depth, when you move 9 from 12, you get 3. 3.00. This is 10 gram. Let's determine the depth in water. The depth in water (12 minus 8), that is 8. Give us 4. Now the next one is 15 gram. Let's determine the depth to go. Seven. 12 minus 7, 5. Then next one, seven. The next one is 20. 10 gram plus 10 gram is equal to 20. Determine the depth it will go. Six. That is 6. 12 minus 6. The next one is 25 gram. 12 plus 10 plus 25 plus 5, making 25. The depth is 5. Depth is 5. That is 7. The next one is 30 gram. 10 gram plus 10 gram plus 10 gram is equal to 30 gram. Drop it there. Drop at 3. 12 minus 3. 12 minus 6. 12 minus 4 is. So we determine the depth. Now we want to find out the time taken for 10 oscillation. This is 5 gram. Drop it there. We are going to put it inside and oscillate it inside the water. As we start oscillating at the same time, we are going to press the stop clock. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 9. Seconds. Now we are going to increase it to 10 gram. This is, we are going to remove 5 gram. We are going to replace it with 10 gram. Then we oscillate it. When we start oscillating, at the same time we are going to press the stop clock. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 8.5 seconds. Now we are moving to the next one. That is 15 grams. This is 10 grams. This is 5 grams. Slot it in the test tube. Now we start oscillation at the same time we start the stop clock. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 8.5. 6.5. The next one is 20. This is 10 grams. This is another 10 grams. We are going to start at the same time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 6. This is 6. Next one is 25. 10 grams. 10 grams. 5 grams. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is 5.5 seconds. The next one is 30 grams. This is 10 grams, another 10 grams. These are 2, 5, this is another 10 grams. 10 plus 10 plus 10 is equal to 30. This one will give us, we start again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On 0, 0. So these are the values. Now we want to determine the L. L is equal to ME over G. This column for ME, this column for D. 5 divided by 3. Sorry. 5, 6, want to calculate the value of quantity L. 5 divided by 3 is equal to 1.667. 10 divided by 4 is equal to 3.500. 15 divided by 5 is 3.000. 20 divided by 6 is 3.333. 25 divided by 7 is 3.571. 30 divided by 8 is 3.750. Now, when we want to calculate the period, the number of oscillation is 10. We divide t, this column, by 10. 9 divided by 10, 0.9000. 8.5 divided by 10, 0.850. 6.5 divided by 10, 0.650. 6 divided by 10, 0.600. 5.5 divided by 10, 0.550. 5 divided by 10, 0.500. Now, to get t squared, we are going to square this. 0.9 times 0.9 will give us 0.810. 0.85 times 0.85 give us 0.723. 0.65 times 0.65 give us 0.423. 0.6 times 0.6 give us 0.360. 0.5 times 0.5 give us 0.303. 0.5 times 0.5 give us 0.250. Now, let us plot the graph. We are going to plot the graph of ME on the vertical axis and T square on the horizontal axis. These are the values of ME. These are the values of M squared. The maximum value here is 30. The minimum value here is 5. The maximum value here is 0.25. The maximum value is 0.81, minimum value is 0.25. So our scale will be on the vertical axis. Our scale on the vertical axis will be will be 0, 5, 10, 0, 5, 0.7 0.8, 0.9, 1.0. This is ME axis. This is T square axis. Now, we want to start when M is equal to 5, T square is equal to 4.81. This is 5. This is 0.9, 0.8, 0.81 will be here. When M is equal to 10, the value of T square is 0.72. 10, 0.72. When M is equal to 15, T square is 0.42. 0.42. When M is equal to 20, T square is equal to 0.36. 20, 0.36. 1, 2, 3, 4, 5, 6. When M is equal to 25, when M is equal to 25, T square is 0.30. 25, 0.30. 25. When M is equal to 30, the value of T square is 0.25. 30, 0.25. 1, 2, 3, 4, 5. So we join them together. Join us together, we have this. That is that. Now, the next thing, we determine the outside value of N. N is equal to L1 plus L2 plus L3 plus F4 plus F5, 1, 2, 3, 4, 5, 6. This one will give us L is equal to 1.667 plus 2.5 0 plus 3.00 plus 3.333 plus 3.571 plus 3.750 is equal to this is Y2, this is Y1, this is X1, this is X2. So our Y2 is 50, our Y1 is 0, our X2 is 0, our X1 is 4.6. This one will give us 50 all over 0.6, which is equal to 50 divided by 0.6 is equal to 83.3. Now, we are going to find the value of K. K is equal to 4 pi square s all over Q. 4 is 4, pi is 22/7 square. Our slope is 83.3 divided by Q. Our Q is 17.82. That is the average of L. So this one will now give us 4 times 22 times 83.3 times 7 times 7 times 17.82. So this one will give us 88 times 83.3 divided by 49 times 17.82. 88 times 83.33 is equal to 7,333.04. 49 times 17.82 is equal to 873.18. So when we divide them together, 7,333.04 divided by 873.18 will give us 8.398. So our K is equal to 8.3 or 8.40 as our K. Now, next thing is that we are directed to state 2 precautions necessary to ensure accurate results when performing the experiment in the laboratory. The 2 precautions are: I noted and corrected 0 error when reading meter rule. The second one is I avoided parallax error when reading meter rule. Now, 3 forces acting on the loaded boiling tube are weight of boiling tube, viscous drag of liquid on boiling tube, and upthrust of liquid on boiling tube. Explain why the amplitude of oscillation of the loaded boiling tube decreases with tube. The viscous drag of the liquid reduce or decrease the amplitude of oscillation.